Okay, this is the pin diagram of your IC. So pin number 1 indicates reset pin number 2 and pin number 7 are the serial data input. Okay, so for left shift DSL and for right shift serial right shift DSR pin is used, and P0, P1, P2, P3 are the parallel data inputs, and Q0, Q1, Q2, Q3 are the parallel data outputs, and S0, S1 are the mode control inputs, and also 8th pin is ground and 16th pin is VCC, and also we need to give clock input. This is the function table that we are going to verify here, and so first we will see the so there are 3-4 conditions we need to check. So first is a reset. So if you can see the MR bit, if it is low, so this is an active low pin. So if this MR, that is reset pin, is low, it will reset all the pins. Okay, and first we will see the parallel load. So parallel load means, so whatever the input that you are giving, it will show in the output. So this condition for getting parallel load is, so the reset pin should be high, and S1, S0, okay, selector pins, that should be high, and we don't care about this DSR and DSL. And then whatever the input that you are giving, that is PN indicates P0 to that 4 input pins, parallel input, that will appear in the output side. Okay, next condition is hold. So if you are loaded first, then if you are loaded, then you can test for this hold condition. So for that hold, this MR reset pin should be high, S1, S0 the pin should be low, and DSR, DSL we don't need care about this. Then PN also we don't care about this PN. So if that is the condition, that means if you keep S1, S0 low at a time, then whatever the output which was previously there, it will hold that output. Okay, so for resetting this output, we need to reset, we need to make this hold bit low, logic low, then only it will reset the output. Next condition is shift left. So this is a universal IC, right? So we can perform both left shift operation as well as right shift operation. So for left shift operation, we need to make this reset pin disabled, so that we will make this high, logic high, and S1, S0 pin, okay, so S1 should be high, S0 should be low, and then DSL pin, okay, you can see here this DSL pin should be high, and the DSL pin don't care about that. Then if that is the case, then this will perform left shifting operation. And for right shifting, so we need to make this condition reset pin as logic high, S1 as logic low, and S0 as logic high, and DSR pin as logic high, then it will perform right operation. This is the trainer kit that you are going to perform all the experiments. So here I have connected the IC, so you can see here, and it is a 16 pin IC, and I have connected power plus 5 volt and ground to this pins. Pin number 8 I have connected to ground, and pin number 16 I have connected to VCC. And now you can see here, so these are the input pin, input switches that are available here, and this first pin, that is there are 2 stages for this pin also. The pin number switch number 9 I have used for S1, and pin number 8 I have used for S0. So these 2 are my selector pins. Okay, similarly I have connected a reset pin to pin switch number 4. So if I make this as high, okay, then I will disable this reset. This is the logic low enable pin. Okay, so if I make this logic low, then the system, the IC will be reset. And similarly, this switch number 5 is used to give DSL, and switch number 6 I have connected to DSR pin, and here you can see the switch number 3, 2, 1, 0 I have used to give the input, okay, from P0, P1, P2, P3. Similarly, you can see there are LEDs also connected, and here you can see I have used 4 LEDs for getting the output, for verifying the output, and here Q0, Q1, Q2, Q3, this is the way that I have connected this pin. LED 3 is connected to Q0, LED 2 connected to Q1, LED 1 connected to Q0, Q1, Q2, Q3. Okay, this is the way that I have connected. The first condition that I am going to check is parallel load condition. So for that I have to make these two pins, selector pins S1 and S0 as high, and also I need to I need to disable this reset pin, right? So I will make this fourth input as logic high, so that my reset pin will be disabled. Okay, now if this is the case, then whatever the input that I am giving here, now you can see both the inputs are 0, and similarly my outputs, all 4 outputs are also 0. Now whatever the input that I will give from here, it has to get in the output side, correct? So I will make this Q0 pin high. Now you can see your P0 pin is high. Now you can see Q0 is also high, and similarly I will make some pins. I will make all the 3 inputs high, and you can see all the 3 outputs are high. That means this is called a parallel load condition. So whatever the input you are giving, it will display in the output. So this is the first condition that we have seen. Now in the next condition that I am going to say is hold condition. So now this is the condition of this output, correct? So what I will do now, I will make these 2 pins, selector pins, logic low. Okay, then what will happen? So it will hold the output, even though if I remove the input, it will hold the output, that you can see here. Okay, now if I want to clear the output, what I have to do is I have to enable this reset pin. Since it is a logic low, I have to make this 0. Now you can see the output is reset, all the outputs are cleared. Now the next condition that I am going to use left shift operation. So for that I will first disable this reset pin, that is pin 4, that you can see pin 4. The next condition that I am going to check is left shift operation. So for that first I will disable this reset pin. Okay, reset pin is connected to pin number 4. Then I will arrange the selector pins. So this selector lines S1 is connected to this 9th input, right? So I will make this high. S0 I will make low. Then 5th input, this pin is connected to the pin correspond to my DSL in this IC. So I will make this as logic high. Now you can see it is performing left shift operation. Okay, and then you can see now you can perform the right shift operation. So for that first I will do I will clear this IC. I will reset this IC by making this as logic low, and then I will make everything off. Okay, now you can see the output is also low, all the outputs are low. Okay, now what I will do, first I will disable this reset pin, and then for right shift I have to make S0 as logic high and S1 as logic low, and also for right shift pin connected to my 6th input. Okay, 6th pin is connected to this DSR pin of my IC. Okay, so I will enable this. Now you can see the right shifting is occurring here. Okay, now you can adjust this clock, you can adjust the speed of this operation by adjusting the clock frequency. You can see here is our option to adjust the frequency. Now it is connected to 1 Hz, right? If you want to slow the process, it is connected to 0.1. Now what I will do, I will reset, and then again I will set this operation. You can see this shifting is occurring, but it is little slow, that you can view here. Yes, so with using this IC you can perform parallel load, left shifting and right shifting operation.